Welcome. This is going to be a little introduction to Holochain, which is a pretty cool uh, blockchain project. And it's not actually a blockchain. So Holochain is a little different. It's structured a little differently from your typical blockchain. So yeah, let's get into it. And then if you have any questions along the way, just ask it. It's just us here, so if anything's unclear, let's clarify it. And then I have ChatGPT here next to me, so if I don't know the answer, I'll ask ChatGPT and we'll figure something out.
Sounds good.
Awesome. All right, so who's the audience? So it's anyone interested in blockchain technology. It's a complex topic, but I'll try to simplify with the help of ChatGPT. And you guys are passing already by just attending, so congratulations there.
Yeah, hey.
So the objective of this course is to provide a comprehensive introduction to holochain technology, distinguishing it from conventional blockchain models and to equip participants with practical knowledge required to conceptualize and construct a decentralized application, specifically a virtual hug HAP utilizing Holochain's unique architecture. By the end of the session, attendees will possess a foundational understanding of the innovative and agent-centric approach of Holochain, enabling them to ideate, develop, and contribute to the Holochain ecosystem. Now, this is kind of a tall order, but and I wasn't able to actually make the hugging hap myself, but I think it'll be a good way to kind of think about this new technology. So yeah, let's dive on in. So all you need is a computer. Visual Studio Code is you could have that if you have it installed already, but you could just follow along too. And you need internet obviously to connect here. And an interest in blockchain technology is always helpful to keep the, because some of this stuff can be a little all over the place and a little confusing. So that interest kind of keeps you sticking around, and then a desire to learn something new. So this is kind of a new way to interact with a blockchain, quote unquote. So here's the course outline. I don't think we're gonna follow it 100%. I think it's gonna be we're probably gonna have questions, and we'll probably have to explore into some of the documentation itself to kind of understand Holochain a little better. But the idea is we're gonna have a little quick introduction. That's right now, 5 minutes. By the way, I'm Shiraj, the Crypto Cowboy, aka, and I am recording this on video, so um, uh, other people can benefit from what we learn here. And then the next 15 minutes is going to be a walk through the documentation. So Holochain has pretty good documentation, very detailed. We probably won't go through all of it, but we'll just kind of hop around the main parts. And then for 10 minutes or so, we'll kind of, probably longer, honestly, we're probably going to go into DNA, Zomes, and cells, and hApps, explained using the virtual hug app as an example. And I think the best way to understand it is through analogies, honestly, because it is pretty hard to kind of conceptualize in your head. So I'm going to be using analogies to kind of enhance our understanding. And then the last 25 minutes or so will be a live demonstration building a simple virtual hug app. So this isn't going to happen, but I will go through the code I have so far, and we can kind of just take a look at it. And it's going to be probably more confusing than not, but it's just kind of cool to see what's going on the code side. And then the last 5 minutes or so, probably longer, we'll just leave it for open questions, and yeah, you guys can ask whatever you want. So, into the introduction. So, I really like this image. This image kind of gets the point across of what Holochain is and how it kind of differs. So, um, I'll just read this out here. So, Holochain is like a set of tools for creating apps that let people connect directly with each other instead of going through a central computer. And this another way to put this is called agent-centric design. So each individual has agency over their data and their own chain, essentially. So instead of the blockchain being a central ledger like Bitcoin or Ethereum, where everything is on the one ledger, it's kind of like a decentralized ledger. Um, and this is actually done with hash tables. Actually, let me message Ofago and see where he's at because we're getting into it now, and I don't want to miss out. Mm-mm. Yeah, you got your hand up, Rajesh. What's your question? You're
Oh,
muted.
sorry.
Oh.
I had it on mute. Yeah. So I'm looking at the diagram here, and I see the blockchain and the holochain. The difference is that the databases are replicated on each participant on the chain, right?
Mm-hmm.
So in a blockchain, to validate a transaction, each node speaks to every other node, right? And I'm wondering how this would scale with holochain because every node will have to speak to every other node for a transaction to be valid.
Yeah, that's a really good question because I was kind of wondering the same thing. And how they organize data is through this thing called a distributed hash table. And with a distributed hash table, they actually don't have it so every node has all the data. It's actually the nodes have the most relevant data, and it's actually done in an interesting way um, where the where the distributed hash table is done in such a way where not all the nodes need to have all the data. Um, and when there's more nodes online, you don't need each node to have as much data. But then when there's less nodes online, the nodes need to have more of the data. So it actually does like a weird balancing act. Um, and I still don't fully understand how that works exactly, but I
Mm,
do know that through a distributed hash table, it makes it easy for nodes to store data in a very uh, like low data cost type of way.
mm, okay.
So so again, this is kind of an agent centric design, meaning people have agency over their own data. So each like cell or node, or I shouldn't interchange those, but each person has their own source chain, which can include private and public data, and the public data is actually sent to the other nodes, where um, it's the data is organized in a distributed hash table, and everyone kind of knows the important data that they need to have to make it work.
Mm,
So
okay.
this is special because it makes sure everyone using the app is a boss of their own information. Plus, it can handle lots of people using the app at the same time, all without needing the big computer systems that are usually in the middle of everything or digital coins that some apps use. So, um, you asked about scalability. The idea with the distributed hash table and being able to only have a certain amount of data on your own chain makes it more scalable because you don't have a central ledger that gets caught up with like all these little details that it doesn't really need to know. So it's a little more efficient with how data is stored, I suppose. And welcome, Jasmina, aka my mom. So yeah, feel free to ask questions whenever you want. So I'll send this slideshow out to whoever's interested. So the documentation is very useful. There's and actually, let's just get into the documentation a little bit right now. So it's pretty nice. They have like a get started, learn, build, resources, get involved. I like how their documentation's organized pretty much. So if you do end up trying to code your own dApp, you could get to the get started part of the Holochain website and check that you basically meet all the requirements. So the hardware requirements are actually relatively high, but they say it's because it's due to the Rust compiler, which requires a lot of system resources. So this is to install the Holochain development environment. So if you want to build a Holochain hApp, you'd want to use their development environment so you can use their building blocks essentially, or templates or whatever to build your application. And yeah, so this is more Cody stuff, and you can literally just copy and paste these into your terminal and try and get their SDK working on your computer. So let's go to the Learn section a little bit. So the Learn section's very thorough, has a lot of details on Holochain. It's an open source application development framework and peer-to-peer networking protocol. It allows you to create actually serverless applications with high levels of security, reliability, and performance. So it sounds like, it's got a lot of good things going for it. Every participant runs the application on their own device, creates and stores their own data, and talks directly to other participants. The security of the application is supported both by cryptography and peer accountability. So really, Holochain's main deal is it's very focused on peer-to-peer interactions. So instead of having a ledger that all the miners are managing, it's really like each user is like communicating with each other. So it's like far more individualistic, I would say. And so here's that image that I was talking about earlier. And I guess let's get into this a little bit. So there's some problems with the centralized architectures. So the client server architecture, which is like the most typical architecture you'll have for a lot of websites and applications now, like Coinbase or even this website we're on right now. There's a client, which is like our screen or your phone, and the server, which your phone communicates with. And that server has like all the data, all the information. So this allows for easy maintenance and is well supported by a marketplace of service providers. It also makes it easy for you to control access rights and enforce business rules. As a focal point for processing and storage, however, it leaves your application vulnerable. When you have a large centralized server with a lot of data, it's an attractive target for hackers, and device and network outages or misconfiguration can take the entire application down. Hosting costs scale with traffic, so you kind of become a victim to your own success. So say if there's a lot of traffic to your website or a lot of people using your application, you actually have to pay more to maybe Amazon Cloud or Google Cloud to host your application or website, which is getting more traffic. And that's how Google and Amazon make a lot of money. Storing private user data increases your legal and moral liability. So, yeah, there's a lot of risk and security that goes into keeping these systems safe. Um, and at the end of the day, we really don't know what data we have that has already been hacked, or um, yeah, what may have happened that, yeah, like there's just so much we don't know that is in the control of a private organization. So this is kind of how Holochain does things differently. With the agent-centric style of computing, each individual holds their own data and kind of uses cryptography and stuff to communicate with each other in a more secure way. So there's a lot of stuff here. I would encourage, if you're interested, to check it out and go through it on your own. I'm kind of just going to glance over it real fast, but I think there's a lot of good information here if you're interested. So the conductor is a very important component in Holochain's setup. The conductor is kind of like one of the main, say, organizers, or it helps maintain the ecosystem, the applications and stuff, and makes sure that everything is running good. So the hApp is hosted in a participant's conductor. So the conductor can be on the computer or on the phone. However, right now, running a conductor on your phone on Android or iOS hasn't been optimized yet. So I think Holochain is working on that, and the community is working on that to bring that into fruition. But right now, I think host you can host a conductor on your computer, but sometimes there's like, you can host a conductor from some server or a more centralized way, and it's kind of a balancing act between how much decentralization you need in the conductor itself. Since the data and individuals are decentralized, it kind of makes the whole thing more decentralized. But ideally, you would have a conductor on every device. So as Holochain develops the technology, you'll probably be able to have it on your phone, a conductor on your phone, or a conductor on your iPad or whatever. So in some ways, you can think of the conductor as a web application server, except that runs on every participant's device. It also has a lot more responsibilities. Not only does it handle local communication with clients, but it also acts as a server and a client amongst other peers using the same application network. It's handling a lot of things simultaneously, which is why we call it a conductor. So if you think of like an orchestra or something, the conductor is kind of managing this instrument and that instrument and kind of making sure everything's kind of coordinated. So yeah, so there's different components to these Holochain applications, the hApps. So let's actually get back into the slides now. So hApps and the conductor. So a hApp, say, imagine you and your friends each have a set of blocks, cells, that you play with together. So the cells, there's cells, Zomes, and DNA, which is kind of the terminology they use to describe their architecture. So for a hApp, imagine you and your friends each have a set of blocks, cells, that you play with together. A hApp is like a whole set of different blocks you were using at the same time. And it's the benefit of this is that each hApp can kind of work with each other, and it's kind of a modular style architecture where you can have like different things interact with each other in different ways, which honestly I have a tough time kind of conceptualizing, but it basically allows for a like modular design, and things can be very flexible, I suppose. So the conductor, this is like the box that holds all your blocks. It helps you find the right blocks and make sure they play nicely together. So I think an analogy would help. So if you think of the hap is like a type of plant in a garden, so you could think cilantro or something. So the hap would be this maybe a bunch of cilantro plants in a garden, and those cilantro plants can interact with each other and do cool stuff like feed people or add flavor to tacos or something. The conductor is like the gardener. So the conductor is kind of maintaining the garden, watering it, make sure it's following. The garden's kind of has a is following the rules to help it thrive, essentially. And multiple plants can be managed by the gardener, each with their own set of instructions on how to thrive. So the there and like the gardener, the conductor can host multiple hApps at one time. So that's just kind of how it's designed. It's kind of very open and flexible design. So cells. So these are the actual blocks. Each cell has its own booklet, the DNA, and does something special on its own. For example, one block might be for chatting and another might be for playing a game. So, in an analogy, I'm not sure if that described it very well, but in our analogy, in the garden, a cell is like a single plant. So there's some cilantro, and you could think of that as a cell for now. And you can think of it in multiple different ways, but this was kind of the easiest for my brain to get, so I'm gonna go with this. So DNA, you could think of DNA as a special instruction booklet for each building block. This booklet tells you what the block can do and how it can connect with other blocks and what it should look like. So following the analogy, the DNA have all the instructions for the plant to live. So the DNA is like each hap, each kind of plant or idea of a plant, even if it's multiple of the same plant, they all have like a single DNA structure that they all follow to live. So the DNA is basically has all the code, all the rules for everything that the plant is designed for. It's the instruction booklet on how to make the plant. So Zomes gets a little interesting and confusing. So these are pages inside the instruction booklet. Each page, Zome, has specific instructions on how a part of the block should work. Like one page might tell you how to add stickers or design your block. So in our analogy, let's go back to the cilantro plant. The Zomes describe functionality from the instructions like the root system or the process of photosynthesis. So the Zomes actually take the DNA and it kind of organizes it into functional pieces that can work with each other. So if we take this to does anyone have any questions on that? Because I know that's probably pretty confusing. It took me a while to kind of conceptualize that.
Yeah, I like the analogy. So it seems to make sense to me. I suppose when we go through more, we may have more questions.
Okay, sounds good. So, um, my idea was kind of to make a virtual hug app. So you would have you'd be a user on your phone or something, and you'd basically it'd be a simple app where you just send a hug to someone else who's using the virtual hug app. And so if we think about this virtual hug app, this is kind of how it would be designed using Holochain's infrastructure. So the DNA, the virtual hug DNA, so this DNA would include all the rules and functionalities for sending hugs within the app. So it would basically have all the code and stuff for sending hugs, receiving hugs, um, like how the messages work, um, maybe some basic rules on who you can't send hugs to or something like that. And then if you look at the zomes within the DNA, so you can have a zome that's the user directory zone. So this zone will handle user registrations or manage a list of active users and provide functionalities to browse through these users. It's kind of like a recipe for a user list cake. And then the hug exchange zone. This zone facilitates the sending and receiving of virtual hugs. It would keep track of who sent a hug to whom and might also manage notifications. Consider this as a recipe for hug sending cake. So, as you can see, it's since this would be a pretty simple app, you would not need too many zones in the app, and one would be for kind of keeping track of the users, and the other would be for actually sending and receiving these hugs, these virtual hugs.
So the exchange is more the functionality.
Yeah, yeah. And the instructions for everything is in the DNA, but the Zomes kind of put everything together like almost like if we go back to a gardening analogy and you say um, the the DNA are like plants, the zones would be like garden beds that kind of put them, they organize them in different spots so it can create some functionality there.
Uh-huh.
So, in the virtual hug app, the cells, each user of the app will run their own instance of this DNA on their device. This means they each have a cell that includes their personal copy of the virtual hug DNA. So, a cell is like a user basically, and and you can actually have multiple users for a single application, um, and yeah, it's a cell has the DNA and zomes within it, kind of deal.
So the cell is that like an instance of the app running for a user, right?
Exactly.
You have multiple users, multiple instances, multiple cells.
And yeah, that would be the technical term is an instance.
Yeah,
Yeah.
yeah.
So the conductor configuration. So the conductor acts like a kitchen organizer, ensuring that each part of the app runs correctly on the user's device. It facilitates the communication between the DNA and the user's app interface. So the conductor could be running on everyone's phone, or it could be running on a web server. Say if maybe you're instead of having like a thing installed on your phone, maybe you're going to a website. There would be maybe multiple conductors that are kind of managing this, or a single conductor that's managing this. I think you can have it kind of both ways, depending on the needs or something of the hApp. So I guess the idea, when opening the app, you will see a user directories Zome that provides a list of all active users on the app and open or have opted to receive hugs. This list is displayed through the user interface on your phone. Then you would have a send hug Zome or function, and you can select one or more users from this list to decide to send a virtual hug. When you send a hug, the hug exchange Zome records this action by creating a hug entry and notes down your user ID and the recipient's user ID. So this is actually an important part of how a cell kind of works. It uses like your ID, and that ID is used to validate transactions or hugs sent or received. Oh,
Will
Adam.
that ID be your wallet ID?
It's actually it's a user ID. I think you could consider it basically like a wallet ID, but it's I think you can.
Like an internal ID.
Yeah, it's just like an ID that gets made up when you make your own cell instance. So every cell has its own ID.
Oh, I see. Okay.
And then receive notifications. So when someone sends you a hug, the hug exchange Zome manages the notification you receive on your device, informing you that you've been hugged. And welcome, Adam, to the class. We kind of dabbled on multiple aspects of how Holochain's architecture is set up, but
Great.
yeah, we'll definitely have some questions, and we'll probably review some documentation and maybe get into some code. So,
All right, great. Yeah,
yes, sir.
I'm excited. I apologize I joined late. I was out of the house, but
No worries. You attended, so that's what's important.
of course,
Did you
of
enroll?
course.
Oh, did you enroll on PSANS Academy?
Oh, dude, no, I didn't.
Oh, okay, all right. Well,
I wasn't on my computer. I'm actually in my friend's car right now too, so I'm not near my computer.
that's okay. It just means you won't get a certificate, but that's okay.
I won't get a certificate. Okay.
Yeah.
No, it's fine. It's fine. I'll have the knowledge. I'll have the knowledge.
Yes. The knowledge is really what's key.
Yeah, of course.
Okay.
All right.
So,
Well, anyways, I'll let you get back to your presentation. for
yeah.
sure.
So getting back into it. So, behind the scenes, networking and data integrity. So, this kind of just gets into the details a little because there's a ton of stuff going on, with this Holochain infrastructure. So for networking, each cell running instance of the DNA on a device communicates with other cells directly without needing a central server. This means when you send a hug, your app communicates directly with the recipient's app. Data integrity. The DNA ensures that all interactions follow the app's rules, like who can send hugs and how you're notified. Each user's device verifies these rules independently. So it's very individualistic, and it allows for like very open, flexible interactions, but at the same time it follows a certain set of rules, which is provided by the DNA. Okay, so let's get some Q&A in, and then maybe we'll get into some code stuff as we get some questions in, and then we can also refer back to the documentation too for the questions. So yeah, does anyone have questions? And actually, I'm going to start this course right now.
All these messages encrypted, right? Between the cells.
Yeah, I believe so. So I think so let's actually go into the documentation a little bit. So the source chain is kind of an important concept because in a typical application, yeah, you're not going to want to share everything with everyone all the time. And so the source chain is basically your own personal chain of validated data. And you can, um, and then there's,
Uh,
you can
I see
determine.
that each journal entry is cryptographically signed by its author and immutable once written. Yeah. Okay, so that answers the question.
Right. And there's public and private data, so you can determine what you want to be public and what you want to be private. So here's kind of a thing here. So detecting third-party tampering. If the integrity of your data is so important, what might happen if a third party tries to mess with it en route to your true love or business partner? The answer is not much. Let's take a look why. So you see there's an action, running instance of DNA, and it goes into an entry, which is signed, and the conductor is managing all this and making sure everything's good. So when a function in the DNA wants to store a user action, it creates a record containing the details of that action and a reference to the previous record. That's kind of how the whole blockchain thing works. Um, then the conductor calls the DNA validation function for that record. If it fails, and if it fails validation, it returns an error to the client. If validation is successful, the conductor cryptographically signs the record with the agent's private key and writes it onto the end of their source chain. So the conductor is playing a key role in making sure that all the data and I guess that everything is signed properly and there's no like issues with the signing and the data. So, like a real life signature, this cryptographic signature proves that it was you who created the record. It's based on cryptographic math, so it's verifiable and impossible to forge. It's also only valid for the contents of that record. If a third party modifies even a single character of the signed data, the signature no longer matches. It's like a fingerprint for data combined with the author's own royal seal. This lets us detect man-in-the-middle attacks on record data, but it still doesn't tell us whether anyone has tampered with the order of the records in the source chain. Let's take a closer look at the action. It includes the hash of the previous action, a timestamp, and the entry type. So previous, and so this is kind of like just how blockchain works. It takes the previous data or block and by hashing it, you're basically hash stands well there's a thing called secure hashing algorithms, and those make it so when you process this data by hashing it, it comes out with the same value every time. And if even a little bit of data changes on the data you're hashing, it'll completely change the output. So it's a very powerful algorithm in cryptography in general. So I think, yeah, this kind of gets through that idea. And then you can see a little bit of the DHT, a shared distributed graph database. So agents share records of their actions, including any data meant to be shared with a group, in a distributed hash table. This database provides redundancy and availability for data and gives the network the power to detect and take actions against corruption. So I think, like I mentioned before, I think before you were here, Adam, the distributed hash table is how Holochain manages data, and it does it in a way where not all the data has to be in a centralized place. The data is actually distributed and in a very efficient way.
Decentralized hash table. That's very interesting.
Yeah, it's a pretty cool thing that I don't fully understand, but it seems very useful.
I'd love to look into the code of it, especially to see kind of how that would work out.
Yeah, let's actually do that. So I did start messing around with Holochain and tried to get their tried to run their example HelloWorld application, but I was getting pretty confused and it wasn't really working, so I gave up. But
What wasn't working about it?
well, it was just acting weird. Like I didn't have system D. I don't have system D on WSL, and it was.
Oh, yeah. That means you have to, were you trying to run like a node? Because WSL does have a service daemon, but it's not system D.
Yeah, so like this thing needed system D, and so there was either it would do it would make me do a multi-user thing, and then I would initiate the daemon separately. But I don't know if I'm just not doing it right or what's going on there. It's kind of weird. Don't get it. And then like when I put the password in, it doesn't actually.
Pseudo password.
It's saying it's wrong, but I know I'm putting in the right password.
Oh, it could be a Unix Windows incompatibility.
Yeah.
I've used WSL extensively in a lot of projects, and WSL doesn't support system D out of the box. You can enable it, but it's a pain in the butt because they use a different service daemon manager to manage services.
Mm-hmm.
So when it's saying system D, are you trying to run a system D command, or are you trying to start up a daemon, or is it part of
It's part of
programming?
Nix. So Nix is like a container they use to run the Holochain scaffolding or the Holochain SDK, the development kit.
Yeah.
So Nix needs system D, but I don't know.
Nix, I've used that before. Wait, give me a second. I'm on my phone right now.
Yeah.
I'm wondering if WSL, you have WSL, or you could have WSL2, right?
I'm using WSL2, yeah.
WSL2.
Okay.
Okay, you're using Nix. Yeah, interesting. I've used Nix in REPL before. Nix, let's see. Is your package heard?
What are you saying, Adam?
Okay, it isn't just a package manager and a case management. In a Docker container?
It's a Nix container that it wants me to run things on.
Run?
So you can see here.
Are you able to run?
This is the Nix thing that I'm trying to get it to run on startup, and it worked a little bit for a second, but it's not like consistently working, and it's kind of confusing.
Okay.
But anyway,
Okay.
we can take a little look at the
Yeah.
we can take a little look-see poo at the code right now, because I'm not gonna figure this out right now, but you can see like this is like when I start it, it's trying to connect to the conductors, and like so in the analogy, so Adam, I was giving them an analogy on kind of how it works, and so basically let's just go back to the slides real fast and just review. So
Okay.
you have cells. Cells are like individual plants, like say a cilantro plant, and then you have the DNA, which is this how the cilantro plant is instructed to behave. Essentially, it has all the rules for how a cilantro plant works. And then we have Zomes, which is functional blocks of the DNA. So the Zomes are like the root system that allows the plant to get nutrients, or it's like the photosynthesis process that allows the plant to convert sun energy into and the air into material on the plant. So let's go back here and see a little bit on what the DNA, what these things are here. So
All right.
let's see.
Is this the project you built?
This is a HelloWorld.
Oh, this is in the repository. Okay, so HelloWorld action hash create entry. Okay, so what happens when you run this?
So you saw when I did npm start, it does this, and it doesn't really do anything after that.
Raj, you mentioned that the conductors are not maybe running remotely, right? So they may not. So the conductors could require some kind of maybe API key or something like that.
I think
no, I don't think it's an API key thing. I think it's a matter of running the conductor locally. Yeah, because I think that's what Nix does. I think Nix like gets the conductor to run locally, maybe. And
however, I'm trying to figure out. Like, I am also curious with respect to the back end as well to this, because it seems like you do have some kind of back end going on there with. So maybe your connector, you have the code there, like Raj is saying, and you have to maybe start those up on the local side up to the WebSocket stream localhost 8888, like routing to that in order to exchange information with that.
That's probably right, but yeah, so I'm just not able to get it running, but I think
is there like a dark? Man, that's really weird that they're using Nix, because in every production project we've used Docker.
Yeah, most of the I see Docker a lot of the time. I'm not sure what the choice there was. Maybe it was a Rust choice because they're using Rust.
Oh yeah, probably.
So let's see what is interesting here. So this is the DNA YAML file. So this is kind of the instructions. So here we have some Zomes right here. HelloWorld integrity. And then HelloWorld.
All right. So DNA.yam also name integrity. So this just seems like some kind of configuration file. Yeah. Maybe I could probably get on a call with you, like maybe like a day or two, and work out running it. I could also try running it on my machine.
Yeah, no, that could be cool. There's also a lot of support on Discord as well. So if you have some issues, so you can see here, I did get a little bit of support, but it still didn't help me. But They do have people who
What you're
are
probably
ready
have
there
to do
to
is either
support.
spin up another VM,
Huh?
spin up a VM. You probably have to either spin up another VM, spin up a system D compliant Docker container that can work with Nix. Like maybe Nix has some kind of Docker container that you can run, and then just work with Docker, which would be much, I think, in my opinion, a lot simpler. Or you could just figure out you could just enable system D on your WSL instance, which I've done before, but it kind of messes with the Windows built-in service management.
Yeah. ChatGPT was basically saying you could enable it, but it's pretty complicated and can have some weird things going on, which I kind of already have now with the multi-user setup. But yeah, I mean, something to figure out for everyone, really, because this is it's an intro thing, so it shouldn't be such a pain to get working. So
Yeah, for sure. Yeah, let's get on like a call in the next couple of days to figure that out.
yeah, we could do that. But let's see, is there anything? Oh yeah, so let me actually. So this is
That's sick.
this is the Holochain Launcher. So it's kind of I guess it has like some sample applications that are out there. So here's a thing called Can Do Test, and it's using Holochain's technology to kind of make a to-do list, or maybe like group management of to-do items. So yeah, it's kind of cool, and it does work, but I was trying to figure out how to interact with other people on it, and I'm still not sure on how that works. It seems like I'm just playing with myself here, rather than multiplayer, basically.
How do you know who else is running that?
It was kind of interesting. Like, so when I choose to install it here, it's like pinging peer hosts over here, and over here it says, so there's 0 available right now, and there's 28 that are maybe have installed this application, but they're not online, they're not responding. So I can't download it.
Okay.
So let's see another one. This is P2P subgroup posting on Holochain. So this was published in last year. Talking stickies. Yeah. Stress test. Test. Afghanistan. Huh. Yeah, so clearly I'm definitely still figuring out how all this works, but that is basically the general introduction to this new type of framework, which I think is pretty it could be, pretty revolutionary. It's just a
100%.
matter of kind of wrapping your head around it and building something with it that's useful.
Mm. Yeah, it seems like all those applications were published around September last year.
Yeah.
There was activity during that time. I'm thinking if you and Adam can have those running, you can probably, do things between yourselves.
Yeah, possibly. That would be pretty cool. But yeah, this is kind of I think the idea is really cool. The whole thing of peer-to-peer, like very purely peer-to-peer. It's kind of like a little more
Yeah.
it represents nature a little more, because that's kind of how we are set up ourselves. We have all our DNA and instructions on how to act, and we basically act autonomously, and interact with each other, keep some things private, and we share some things with others that are useful. And we don't have like all the knowledge of everything, but like separately we kind of know everything in a weird way.
Awesome. I have to bounce now, unfortunately, but if you could send me the slides, let's definitely get on a call in the next couple of days, and I'll help you try to set up Nix with WSL, because I also have WSL on Windows as well as.
Cool, Adam. Yeah, that sounds good. I'll send you this right now, actually.
Great.
And they have a lot of documentation, so.
Well, thank you for letting me attend.
Yeah, no, thanks for joining, Adam. Hopefully next time you'll actually register on the pSense Academy, but this totally works for now.
Yeah, you'll get a certificate.
I will.
Hey, what email should I use for you, Adam?
Adam B at csxlabs.org.
Adam, was good seeing you, yeah?
It was good seeing you as well. Anyways, have a good rest of your day, guys.
All right, see you,
All
Adam.
right.
Yeah, Adam.
Yeah.
Hey, Mom, you have your hand up? Do you have a question? Your mic's muted.
Sorry. Yeah, I was just saying goodbye to Adam.
Oh, okay.
I'll turn it off. Okay, thanks.
Okay, cool. So yeah, does anyone have any other questions on Holochain? James, you got a question or anything? Or how do you feel about the whole pSense Academy flow or anything?
Yeah, I appreciate you inviting me and everything. I guess I was wondering if you could give me like an example of a use case for this, or something that you and Adam, what would be a good use case for you two to get started?
That's a great question. So the guy I actually met at ETH Denver, he founded a startup called Internet of Energy Network. Let me see if I can find that. Right. Huh. Let me just get it on Twitter.
It's the warning here. It says the score will end in 1 minute.
Oh yeah, it's
Do
probably
you have
gonna
a
end in 1
timer
minute.
on it or something? Yeah.
It's just Google's natural thing. So what he's making is a very cool energy sharing type of deal. So people can generate energy and prove that they generated that type of energy and send it or share it with someone else who needs the energy. And so it kind of takes away the idea of a centralized power grid like PG&E or something, and it creates the whole use case of like maybe everyone has solar panels and they're able to share that energy. Oh yeah, there you go. And that's all she wrote.